Thank you so much for being here. My name's Julie. I'm from Wales, and that is a country, not an animal. What I'm going to talk about today is how we use data to have conversations and to take action where I work in Cardiff. So can I start with a show of hands of everyone here who's seen The Matrix? Know your audience, right? Thank you very much. So in The Matrix, as you all know, our main character, Neo, he gets a choice. So he can take a blue pill or he can take a red pill. If he takes the blue pill, he gets to go back to his life, he gets to believe whatever he wants to believe, but it's the choice of him putting his head in the sand and being ignorant to what's actually going on. Or he can take the red pill, and the red pill represents an uncertain future, but the truth about what's going on. So he learns an uncomfortable truth, and he gets the opportunity to take action and influence the future. And when it comes to software delivery, I believe we have the same choice when it comes to data. So we can take the blue pill, and we can keep looking for certainty and believe the illusion of the estimated date. Or we can, or we can use the red pill, and we can use data that gives us the truth about what's going on. And that is that software delivery is uncertain, and we can't possibly know the outcome on day one. And the efforts we put into looking for that certainty can be really wasteful. So I'm going to spend the next 30 minutes taking you down the rabbit hole and showing how we use data to have conversations and avoid the illusion of the estimated date. A little bit about me. I'm Julie Starling. I work for Principality Building Society, and that's a financial institution. It's a small mutual business in Cardiff, Wales. I'm a pro Kanban trainer, and I'm also the practice manager for Agile Delivery. I get to look after all the Agile professionals in the company and help them to grow the skills in their teams and the wider organization. So I've been working in and alongside software delivery teams for more than 15 years now. And I'm really passionate about using data to have conversations. So I'm going to talk a little bit about where we were and where we are today. So about 6 years ago, we used to have big programs, we used to have planning days, we used to spend a lot of time estimating. And because of that, we were quite often chasing deadlines. So I hope we all know here that, an estimate is just a best guess with the information you have and the experience you have under your belt. So quite often they're wrong, they're not going to be right. So we used to spend a lot of time re-estimating, trying to get better at estimating, trying to work faster. But actually what we were doing was solving symptoms and not the problem. Trying to get to certainty wasn't working for us. So today, we now use a more probabilistic approach. We use probabilistic forecasting and have continuous conversations about the data. We look for signals in our data for telling us if we need to take action and we need to do something to influence the future. Alongside that, we also use flow metrics, and that helps us to continuously improve and also to look for signals on a day-to-day basis with our teams. So what is late anyway? So there's a really obvious interpretation of late, but to me, it represents mismanaged expectations. It means someone was expecting something certain by a certain date and they didn't get it, which means we've likely been planning for that certainty in an uncertain world. It can also be really demotivating. Lots of times I get told, you need to have a deadline because it drives urgency. If you don't have a deadline, we'll never get the thing delivered. And in my experience, it's exactly the opposite. The more often you're late, the less you care about being late because you're always late. And that drives really unsustainable behaviors. So that's when we start to see things like people might be working overtime, we might build up a bit of technical debt, and we'll definitely get around to that later, or we'll cut corners. But most importantly for me, it is a lost opportunity to take action. It means from the time you set that expectation to being late, something you weren't expecting happened and we didn't do anything about it. And if we're using the wrong data, it's not that we chose not to do that, it's that we didn't see it happening. This might be a little bit flippant, but I never resist an opportunity to quote Douglas Adams. So as I said at the start, we're a financial institution, and deadlines really do matter to us sometimes. We're regulated. We don't always get the choice. We have a mix of delivery types, so we have some product-based work and we have some regulatory-based work, and this approach works for both of those. Sometimes we do need to check ourselves. We're not perfect by any stretch. We do need to make sure we're not slipping back into old ways of working, and it's easier with some stakeholders than others, which I will get onto. So I'm going to show you some real examples of real data of where we've done this, and just see where we've learned along the way. So I'll start by, what do I mean by probabilistic forecasting? So it's the same as when we're talking about the weather or when we're talking about economics. What we're saying is we're using past and present data to make a prediction about the future. And a forecast, a probabilistic forecast, always has a probability and a range. Here are two examples of a probabilistic forecast. You'll notice they look slightly different, and that's because they're answering different questions. One's saying, how much am I going to get? And the other's saying, when am I going to get the thing? So the probability part of this statement is the percentage. At Principality, we use 85%. That's not right or wrong. That's just what we've chosen to use. And you need to remember that when you're saying there's an 85% chance of something happening, you're also saying there's a 15% chance that's not going to happen. So it's really important. The range part of it is either the days or the number of work items, depending on what question you're asking. You'll notice there's no certainty in either of these statements. However, the first time you share these with people, they will look for the certainty in those statements. So the first one, for example, people will say, oh, I'm getting my thing on the 31st of June. That's not what that says, and that needs to be part of the conversation. And we need to do this continuously. This isn't something we do once a month or we put in a backpack and send off to exec. This is something we're doing all the time, and we're having continuous conversations about it. So what do you need to be able to probabilistically forecast? How do you start? So it's really simple. You just need the cycle time of 10 or more work items that were done by the same team, and the future work needs to look like the past. And that is it. I'll break that down a little bit, though. So cycle time, I think if you go online, read definitions, there's lots of different definitions of what people think that is. What I mean by this is just the start and end of your system, whatever you define that as, that's what you're forecasting for. And when I say the same team, you can't use one team's data to forecast for another team. That's not how it works. And when we say the future work needs to look like the past, that doesn't mean you need to be doing the same thing day after day. That's not how software delivery works. We all know that. But what it does mean is you can't fundamentally change your entire tech stack or maybe change the way you break down work completely and expect to use the same data. But since we only need 10 items, it doesn't take long to get that back. So once you've got that, you need to run a Monte Carlo simulation. We use Actionable Agile to do this, so you don't have to. There are other tools out there, but this is the tool that works for us. I'm not really going to get into the guts of Monte Carlo simulation because I've only got about 20 minutes left. I will give some resources at the end, and please come and speak to me today if you want to talk more about it. But I'll give you in a nutshell view now. So you have your data, and you ask it a question. So like, when am I going to get this thing? And it'll run a random simulation on that data and pop out an answer. But it doesn't do that once, it does it thousands and thousands of times. In fact, on this example here, that's 1 million simulations run. So when we say there's an 85% chance of something happening on or before a date, we're saying out of that 1 million simulations, 85% of them came out on or before a date. That's the in a nutshell view. I'm not going to go any further than that, but please come speak to me if you want to. So I might sound like I'm contradicting myself up until now. So I'm saying estimates are wasteful, you know, they're not accurate, but we should probabilistically forecast and we should do it all the time. The difference is estimates use people. They take knowledge and they take people away from the work that they would be doing to add value. When we probabilistically forecast, however, we're using data. We can run this several times a day, and it has no drain on the team. It takes seconds to run. Also, estimating is really hard, right? It's a really hard thing to do. You have to try and guess what's going to happen between now and then without all the information. Sometimes we think about effort instead of elapsed time. We can't factor in our context switching. We don't know how many meetings we're going to be in. But when you use real data, that stuff's already happened. That's in your data. So when you do your simulations, it's taking account for those scenarios. really topical, and I didn't plan this, but the weather in Amsterdam this week has been a bit unpredictable. So when we think about weather forecasting, we accept that actually the forecast in a week's time is not going to be accurate. So this is what I did for Cardiff 7 days ago. I did a forecast last Friday, and that was a 7-day forecast. That's a little bit sunnier than Wales normally is. So I did the same again on Saturday, and as you can see, there's some changes. And then I did the same again on Sunday, and there are some changes. The point here is it's better to be approximately right than exactly wrong. It's better to have the conversations every day and to be looking at what's changing and what's happening and planning for the future based on the new information you're getting. Weather forecasting is really complex and we get more information all the time. Software delivery is exactly the same. So I said I'd show you real data, and this is what I'm going to do now. So this is a team that we had about 18 months ago. They spun up a new team to try out some new ways of working. We had some features to get through, and this is going to be their data. This is not it. I'm going to add it now. So I'm going to add a red line on here, and this line is going to represent the amount of work we have left to do. So if this line goes up, it means we've got more work left, so it could be we're uncovering complexity, it could be we're adding scope. And if it goes down, it means we've got less to deliver. So we could be working through the items, cutting scope. So here we go. Day 1, team starts delivering. The line's going down, exactly what we'd hoped for. I'm going to introduce a second line to this chart now, and this is going to represent the forecasted date range of work left to do. If it goes up, our forecasted date range is moving out. If it comes down, it's moving in. So here we go. You'll notice it's not started on the same day as the red line. And as I mentioned, we need 10 or more items to get started. So we waited for a little while before we started forecasting. But what you're seeing here is the forecasted date range for the number of items we had left on that day using all the data we collected up until that point. So the team keep delivering. Our red line is going down. Our forecast is remaining relatively stable. That's good news. So we're not changing too much. And then this happens. So our red line flattens out, and our forecasted date range is moving out. So this is a trigger for a conversation. This is what I mean when I say we get the earliest possible opportunity to take action. This could be a number of things, right? We could be uncovering complexity, we could be blocked, but the whole point of this data is that we're having the conversation. What actually happened was the team got a little bit involved in a quite gnarly production issue. Really helpful of them, but they were completely the wrong team to be helping with this. So we had the chat, we got the work moved into another team, and they were able to keep delivering. So I'm not saying that's always the answer, moving work around. It's not. It was in this scenario. But when we did that, the number of work items started to come down, and our forecast restabilized. So what you'll see now is that our forecasted date range is now later than it was before. So this gives us an opportunity to manage expectations or do something about it. Do we want to cut some scope? Is there something else we can do? Can we ask for help? Or do we just have a conversation and say, look, this thing has happened and our date range has moved back? Before, this is the type of thing that would happen along the way that we probably wouldn't think, oh, we need to re-estimate. And these are the little type of micro events that happen along the way that influence our end date, but we don't always think about re-estimating all the impact it's going to have until it's too late. The next thing that happened in this scenario, and I don't know if any of you have experienced this, we had from a stakeholder, whilst you're in there, can you just do this as well? So normally there are 2 ways we would deal with that. We'd either just absorb it and keep going, or we'd re-estimate and spend time doing that, which meant this time we weren't working on the value. With forecasting, we're able to quickly run a simulation and say it probably will look a little bit like this, and we can have a conversation about the cost of that choice. We could do that before, but with data, it makes those conversations a lot more tangible, and it means we can have sensible conversations. So hey, can we just stick with smaller batch sizes? We'll get to this next. Do you really want it at this cost? So yeah, enable the conversation. So we do need to talk about the people side of this. I spent a little bit of time at the start gathering data so that I could go and have these conversations, tell people what the intention was, spoke to teams, heads of departments, and really easy to get nods. So I'm going to be able to manage my expectations, you're going to give me options, all sounds great. And that is until your forecasted date range starts moving in the wrong direction. And when that happens, we really need to double down on the education and understand that forecasting hasn't removed any certainty. These things were happening anyway. You just now have more information than before. You know about what's going on. And we now have options. And the options are when we can do something about it, not when it's too late. And if we were to aim for certainty, yes, we could spend some time in a room re-estimating another wrong date. But actually, that's time we're not spending on doing the work. So we were capturing cycle time for our probabilistic forecasting. And I could also show that we were capturing flow metrics just because we had those two numbers. So as I said, cycle time from the start to the end of the system. If we imagine all these green dots are work items flowing through the system from the start to the end, if we've got an item that's got a start date but not an end date, we know exactly how old that is, and that's our work item age. If we add up all those items that have a start date but not an end date, that's our work in progress. We know exactly how much we have in progress. And finally, everything with an end date, we know the rate at which we're delivering, so we know our throughput number. So again, I'm going to show you some real data examples for this, but for work item age and work in progress, these are numbers that exist in our system. So when our work is still live and active, so before it's been completed, they then become cycle time and throughput. So cycle time and throughput numbers are for when items have finished and exited our system. And cycle time is such an important number because that represents the amount of time it takes to get feedback from our customers. So this is a cycle time scatter plot. Each of these blue dots represents a work item. For us, that's user stories. For you, it could be anything. It doesn't have to be stories. It could be tasks, features, whatever you want to represent with this. So the bottom axis tells us exactly when we delivered that, and the y-axis tells us how long it took, so our actual cycle time. This was a real team's data from 2018 when I introduced them to flow metrics. And what we can see is a lot of the items were taking longer than a sprint to deliver, so this team was working in sprints then. So we had a bit of a conversation about this, and was like, what can we do to actually help this? So we agreed we would limit our work in progress for a couple of sprints and see what effect that had. We had some really interesting conversations off the back of that, so a lot of the team felt really uncomfortable. They're like, I don't feel as busy, and they were so used to context switching and working on a lot of things at once. That had all gone away. Then we looked at the data, and the data showed us that actually our cycle times are significantly reduced, and we hadn't impacted our throughput at all. So we could then have better conversations of, if you're feeling this way, is this just actually because you're not burning out? Or is it because you have some time and we need to look at maybe adjusting the work in progress limits? Or could we put that effort towards personal development? So when we've got a cycle time scatter plot, we can calculate what's known as an SLE, a service level expectation. So this is, the only difference with this chart now is that we have percentile markers on the side. So if we look at the 85th percentile, what we're saying is for this time frame, there are 85% of the work items under this line. So this says that there's an 85% chance of delivering a work item in 21 days or less if this is how our system performs. However, we need to be really mindful of the data we're using. So we've done an experiment here and significantly changed our ways of working. So before the experiment, it was 25 days or less, and after, it was 7 days or less. So once you do make a significant change, and you're seeing that in your numbers, when you're doing your forecasting, you need to be mindful of the data set you're using to do that. But since we're part of the conversation and everyone's involved in that, everyone's aware of what's going on, so it's not normally a difficult thing to know to do. Everyone knows Schrodinger's cat in a box? Don't know if it's dead or not until you open it. Yeah. So let me introduce you to Schrodinger's work item. So my theory is inside our system, an item represents both potential value and waste, and until we deliver it, we don't know. So yes, we've been talking to customers, they tell us they want it, we think we're delivering value, there shouldn't be anything in our system that we don't believe is valuable, but actually until we deliver it, we don't know. And the point here is we want to keep things in our system for as small of time as possible. So how do we stop unnecessary aging? And this is of work items, unfortunately, not people. I don't have the answer to that. So one easy way is don't start, right? So this doesn't mean we don't do any work, but it means let's not start items until we know they can flow through the system. And then finish them. Once they're in there, let's focus on getting them done. So I realize that's really simple and not helpful. So actually what we need to do is not start work items until we can get them through the system. And when they're in the system, we need to be managing that work in progress with the goal of finishing. So there are a number of ways we can do this. So we've already talked about limiting the amount of work we have in progress. We also want to keep items small, so that small batch sizes, small work items. That means that they have less resistance going through the system. But importantly, we need to take action on items that are unnecessarily aging. So you might be thinking, how much age is too much age? How do we know? So we looked at a cycle time scatter plot, which was items that have gone through the system. These are items that are still in the system on an aging chart. So this is a really simple representation. We have 3 work items in here. One is 3 days, one is 6 days, one is 12 days. And we've already talked about an SLE. We've calculated one of them. So we just overlay it on here. And we can have really good conversations about items that have gone above our SLE or are creeping towards and might need action. So it might be that, I don't know, we might need to break it down. It might be blocked. We might need to say, actually, do we still need to do this? Is it not moved because no one cares about it? So it lets us have those type of conversations. Can you please shout out what you believe the story point number is of that very top item at the top? It's taken 60 days to complete. Give me some numbers, what you think the story point value of that was. 2, 5, 3, 1, 9, huge amounts of variance. So what I'll do now is color code these to represent the story points that were given. Ooh. So you'll see it was a 3, as was all the items down here on the 1-day line. Even after our experiment, there's a 10-day variance in those. There is no correlation between story points and time. There never was meant to be, right? That's not why they were designed. Yet for some reason we use them for planning and we use them to manage expectations. So I'm not here to hate on story points. If you love story points and you get value out of them, crack on. But what I'm challenging is we should not be using them for planning and we should not be using them to manage expectations. So thank you for staying with me so far. So I've talked about probabilistic forecasting because software delivery isn't certain and we should stop treating it like it is. We need to be having continuous conversations to manage expectations. There is no point in us having this data if we're not talking about it. And let's solve problems along the way instead of symptoms when it's too late. And also, we've been using flow metrics to help us get feedback quicker from our customers and continuously improve along the way. I said I'd share some resources. These are them. If you're interested in probabilistic forecasting, I would really recommend the 2 books on the end or the top link. I will try and share these with the conference as well, I think, so everyone can have them if they want it. And yeah, I've been Julie. Thank you.